Do. Oh, hello there. I know. It's so freaking late. But this is apparently when I have time to do things. We're going to be traveling tomorrow, so. Ah, uh, exit out, blah, blah, start fresh. All right, I spent some time playing around with ChatGPT earlier, and I'm like, oh, I'll just put this data into a nice little chart. You could make the chart easy. Put it in the Wolfram language without errors. That, my friends, was not easy. Still isn't quite working, at least the way I would like. No, I can do it. This requires just learning how to put the right head on and whatnot. Probably sound wrong. Oh well, we're just gonna keep on doing our thing, so we at least have it in a notebook. Even if, oh wait, probably share. Exactly 17. All right. The long story short, we compared this expression, the gravitational force, and made it dimensionless. How do we do that? We just throw big G, multiply it by a mass squared, divided by h bar c. Will give us a dimensionless number. The the thing that I did, basically, if you throw the Planck mass in there, you'll get one. Yeah, basically, yes. The Planckian scale, the Planck mass equals one. Our basis. But long story short is if you divide by h bar, you're going to get a number out in joule seconds. The reason why I'm doing this is, or at least my argument, the it appears that the Higgs mass is approximately 1 joule second. So I find it interesting that hypothetically, if we were to scale the Higgs boson by the squared the root of action, aka h bar divided by the reference of action, the joule second, um, this equals one. So the Higgs boson's root mass basically is tuned to about 1 joule second, or at least it would come out if you're dividing it by that, because that would be tuned by the square root of that. So when you square that, this is all going to like cancel out. I realize with no other backstory, that's kind of a lot, but this is a working session, what it says. So let us continue. All right, so that's it for particles. Okay, so we've made the argument I not be the case. Okay, so this is by no means an exhaustive analysis, but the author found it interesting that our unique, our one unique scalar boson returns 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 a value of one one in the one in the value of about one, the reference. Interesting that our one returns are by no means an exhaustive analysis, but the author found it interesting. Our one unique scalar boson using the ele- using the one unique scalar boson. mm, One unique scalar using the above method. In the above method of including the elementary. There should be two sentences. By no means an exhaustive analysis. Interesting. One unique scale, uh, one unique scalar boson returned near unit results. Uh, Again, one may argue this is a contrived technique, and yes, it is. However, the above semicolon, that's what we're going to do. Yes, the laws is two sentences. Ah, it is. However, the above method of including the elementary unit of action unit of H bar. Unit of action. Or the above method of including the elementary unit of action, H bar, and returning a value of 1, approximately 1, in the reference of action was intriguing enough to continue. All right, justification for continuing on with any more words. All right. You use elementary unit of action outputs basically the reference of action. Why? Because when you do it here, Higgs math squared, we got our big G there, H bar on top, H bar on bottom, and C in the bottom too. It outputs approximately 1 joule second and 10 to the 7 ergs. You can tell I've spent far too much time on Wolfram Alpha. Oh, God. All right. Good words. Hey, Vaz. Yeah, yeah. And we'll get these into all the little tables and everything that we need. Yeah. Save to cloud. Oh, nice. Friday? Oh, God. Good night. Dave. Oh, I have water. Yay. Mm. Hydration is important. Probably also see if the stream is actually broadcasting. Thing is, this isn't the type of thing that people are just jumping on because, well, come on, just a random dude here. Okay, all right. It's sorry, I have it low res on the other screen there. Just want to make sure because I don't know something about AirPods. Seem to like to work once in a while. We gone through this analysis. Did we? Okay, so we did the particle masses. This is all technique number two. Okay. It's technique number two. What do we do? Let's go to let's take self-interaction. Good one. Got that? Because if we do this, basically if we use this expression here. There we go. Oh, just one giant section up there, basically. Is it? I think it basically is. We just for the inspiration for alpha using just our basic computation. Okay. Oh God, that was all just two different techniques and just comparing to make sure it wasn't just a okay. Higgs. Oh. If we if we assume there is there, so to speak, we can use this number, we can use this value we elated for the Higgs mass like with the above techniques and use the value we calculate for the Higgs mass to search for potential closed forms for its interact. This sounds like a crazy thing to do. And use the same phrasing. No, let's just continue on. Let's not even state how crazy it is. We've already said this is all contrived, so we will add it in. Now we need the Higgs interaction. Is that in the Wolfram language? I think so. It's- hmm, Formula. Formula. What's it? From special theorem predicts values of Higgs self. The cubic, quarter coupling, six mass and weak scale. Well, Higgs potential standard model is electroweak. Uh, uh, Higgs bosons and reserve. It's giving me. I have this, of course. I know it's so exciting, isn't it? That's we obviously figure out all these things. Over here. Okay. The W boson. Calculation. I need the Fermi interaction. God. Oh, because this is how we actually derive it from a given measured number with high confidence. Just copy and paste it. This is. Where are the links? It's, I don't know. I like Wikipedia just because I'm familiar with the layout. One lifetime, I think it's the W boson. Terms are reduced during constant as the constant and natural units is. Ba, 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 ba. Yes, it's inverse energy squared, so we need to invert it and take its square root. Ooh. 5. Explaining it hadron colliders. Quartic. The 3, blah, blah, 240. EV. 2005? We didn't even discover the Higgs boson yet. Oh, all right. Oh, it was 120. It seemed. All right. A constant. Oh, and the standard model. All right. So the lambda standard model is the Higgs square divided by. Okay, it's got what we need. Yeah. Okay. Cool. No, I'm not sharing what I'm viewing right now. I'm a terrible host. We think the electroweak symmetry is broken, a general parameterization with one doublet, as in the standard model is this, where, all right, so B is the square root of Fermi, square root 2, Fermi constant, and then we take the square root of that. Is the vacuum excitation value, G of S Fermi constant, of the lambda 0. So that's the theory. Two otherwise three parameters. And the trilinear, two otherwise three parameters, namely in a cortex scale couplings and upper can be determined using unitary arguments, assuming the model's validity to high energy scales, and all the two self couplings are linked as the Ewing terms in equation one, namely equals V. Higher dimensional operators are not expected to appear much below Planck's scale, an intermediate scale. Include higher dimensional terms, the self coupling receives different corrections, blah, 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 blah. There's a lot of terms, some of those familiar, not in general, it's not even guaranteed that both couplings have to be positive, since the ability, the general Higgs potential is guaranteed by the sign of the highest power in the Higgs field alone. So many things. Okay, so let's do this. Paper first, Wikipedia first. It's laid out in the way I like it. No, so much by it. On the first page, the other things. Somebody really wants to go in, you can go in. I just trust, verify. Where was this? There goes the square engine. Here, literally just stealing this from Wikipedia. All right. Yeah, I mean, it explains it pretty well. Do I have to do the weak mixing? Oh, I got that stuff. I think everything in here is actually computable. Hmm. Uh, Berg angle. Yeah. Were you mixing it? Doing that before? Uh, let's. I mean, we can. I think we actually calculated. Maybe not. Like some other G the other day. I was going through, and I'm like, oh my God, I'm so wrong. Um, it wasn't far enough off that I was completely wrong, but I was confused. Long story short is rather than okay, I realize I'm hovering over something on a web page that I'm not showing right now. Long story short, I'm hovering. The Fermi constant's about 246 electron volts, but at 248, I'm like, what? Why is it close, but just far off? I'm like, oh my God, I was wrong about everything. And this, I'm just gonna literally say it almost verbatim. All right. Uh, all right. The stand. They capitalize? Okay. Standard model. Standard model is the Higgs vacuum station you to be all right. Square root 2 Fermi constant, square root the whole thing. To be square root is the square root of 2 Fermi constant. Oh, enable dynamics. Yes, need our magic. Oh, Wolfram. Oh, sorry. I did it wrong. Inverse root of 2. Need to raise it to the -1. -1/2. There we go. We got to invert it to turn to actual energy because I'm when Nobin didn't actually read this. All right, there we go. Now we're in energy. Look, one one over two to the fourth root. Oh, very neat. Yep, there we go. RGV. Oh, energy. Yeah, the stuff and things. Uh, and then- delete this one because we did the wrong thing. Roll that up. Roll that up. We want the unit conversion. We want the 3 through 5. Feel this one. Ninja. Iron. Yay. Ninja. Go ninja, go ninja, go. Go ninja, go ninja, go. Go ninja, go ninja, go. Go. Ergs. You ever get the erg? Ah. Meters microjoule. Okay, we got ours. All the stuff that we're. That's yeah. All right, I think. Oh, that's neat. It's roll it up. Now it's hidden. Haha. Oh, actually, they erase the negative two. Erase to the -1. That's monkey. All right. Yank you out there. Save. Save as. Higgs. Say 19. Uh, File. Saved cloud. I need to go to code data to actually get enough significant digits. This might get us. I think it's gonna get us to the ballpark, folks. So we shall see. Welcome, awesome run. The Higgs cow is doubting if I'm real. I'm just a figment of your imagination. Something I told Dream Tabitha. Consistency, consistency. I lack that. All right. So Higgs self interaction. Blah 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 blah. It's okay. Again, this might just be a whole bunch of bull, but if there's something there, it explain a lot, and it's at least worth exploring. Okay. So we've got that. So hold on. The Fermi interaction. Okay. Fermi constant. Wait, so which one is Fermi interaction? Fermi constant is interaction. I'm literally just like looking for one thing. Don't I'm not gonna pretend like I understand all this stuff. I should at least try. Just want the dang formula. I mean, I know what mathematical formulation of the standard model. This is actually probably some of the easier math. The sad part is about it. Ah, it's crazy. All right. Yes, because this is obviously, I think, yeah, this is our Lagrangian for our standard model. The standard model. And the crazy thing is, that's a lot of rolled up notation. If you wrote that out in code, whoa. Oh, the full extended standard model. Oh, is this? Okay, maybe that is everything then. Okay, sorry. I stand corrected. When you say fully expanded, how much is that? Because it isn't like the Einstein, like general relativity, like 10, 10 by 10 matrices or something. I don't know. The things I heard. Coupling constants. Mass terms in the Higgs spectrum. All right. Complex scalar field. Here we come. Blah, blah, blah. Getting the W boson, mass of the Z boson. All right. All right. So here's where we're basically computing. Here's what we're going to claim to leverage. The mass of the Higgs boson. All right. So we're literally, hold on. So we're just going to take that term there and literally say, you are right. This is the term here. So, maybe it's literally just like I'm like, oh, wait, if you fall into one, oh, it might just, you think you've been kicking the ball game. Maybe it's made up of smaller things. Oh. So, all right, don't re-break everything. Per the standard model, the Higgs is Higgs mass is defined. Do this. Why is there no? Oh, it's in the other article. Okay, term. Uh, two, otherwise three per. Oh. And the zero is okay, this is very good then. Just reading this, it's like if we consider standalone effective theory, lambda zero stands for two otherwise three parameters, naming the trilinear and perfect scaling self-coupling. Using unitary arguments, using the models validity at high energy. Okay. All right. I don't know how to go through all of these things, but that's very cool. So if one of these things is a dimensionless thing and that covers two free parameters, that sounds pretty good. I don't know. Two for once. Okay. So what it is okay. So I'm gonna need to do a lambda zero. It literally also says in the standard model. So and as the lambda. So fancy things. Evaluation form. Uh, Special care. All right. Get a lambda. Big lambda. Not that one. All right. All right. Lambda zero equals lambda standard model equals lambda again. Lambda. Uh, Hit it into SM. Oh, why are you being difficult? Let's just do the text format. Typesetting. The, why is this all? This all be a thing? So it's connecting it. And just something weird again. Tell me something weird again. I don't want it to all. Why do you need to do all these stupid things? Uh, Here. There's a period. I'm not even gonna put the equal there. I'll put it at the end. God, I'm such a hack. If this does. Standard model. Now, what the heck was that data? The Higgs. If you even put it here, it was a pain in the ass. Even put it in there. Sure, that's not it. Oh my God, it worked. Ah. That's the Higgs. Word. Divided by 2 vev squared. 2 vev squared. Ooh. The vev is the funky V. V is it? Recursive EV or V, V, V. That one. Is it upsilon? Upsilon. Oh God, no, that's a U. It's not the V. Oh wait, sorry. No, I'm not even sure if that's what it is. Let me just copy and paste it. Eggs. U. computation value B is pronounced. The vet, yeah. The symbol, pronounced V. The letter V. Okay. It's literally just V. It's just a cursive V. I thought it was Greek to me. I can just V. Format. Doing. That doesn't look Italian. Ah, all right. God, the paper. I'm just copying that whole dang expression. God. Do V. There we go. Make it italic. Standard model defines the exact expectation value V to be by 2V squared. B. That's, yep, 2V squared. Oh, because you insert that. All right. Where was the Higgs mass defined? It's basically the same thing. You just change around some factors. Mathematical model. Of course, it's no math. All right, let's do this. We have, it's basically one has square roots, the other doesn't. That's literally the difference there. I'm sorry, I'm going back and forth between two papers. They're Wikipedia's, the self interaction. This is actually by the paper. Stands for the trilinear and quartic self presents the presents. Or I don't know enough about that. I worked through all that. Yeah. A reaction between the Higgs mass and self-coupling as well behind. The paper I'm going by, we discovered it like 7 years later. Hmm. How do they have the other one? I don't want to use the wrong term. Hmm. It's gonna be in Hermes interaction. Hmm. The other way. Where's Lambda? Sorry, I'm on the other page. I know. So exciting. Those guys there staring at a notebook and not doing anything. I look around June where lambda is greater than zero. Okay. Check. Mu squared is greater than zero, so the mechanism response using a symmetry breaking can be used as a parameter for setting the shape of the potential. Blind is a non-value expectation is also true. North Station, blah 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 blah. I'm so stupid. I literally just plug it. I'm like, what's the missing piece here? Okay. So the Higgs mass, the Higgs self-coupling strength. No, it's just lambda. That's all we're doing. Not gonna do lambda zero. Too much. Presents presents the Higgs. Let me say it's self-coupling. Instead of coupling. The standard model, lambda represents the Higgs subcoupling strength. That in. Actually, let's see what it is. Higgs squared divided by 2, the vacuum expectation value. Higgs fume expectation view. They only have it the 3 digits. And I'll do it anyway. Oh, compute. Oh, that did not work. Okay. It's d squared. D squared is required unless I want to divide that by Bird energy. Oh, it's better. User error, of course. Supposed to know this. The whole thing. Algebra is not that good, and that's what I'm relying on. There we go. Now we're dimensionless. There we go. All right, that's that basically what the standard. Most of the measurements are showing us so about 1.3, 1.3-ish. Right there, right there. Thank yeah, yeah. Progress. David Higgs. I D. All right. It's the cloud. All right. Oh, at least I know math song. The song that never ends. Oh, yeah, no, that's probably just because I'm talking in front and it's blocking the stuff and things. My apologies for that. It's mostly me murmuring. It's also late at night and I'm going for over an hour, so I'm gonna take this offline and crank out as much as I can. Thank you, everybody, for who chose to watch, to be here for this train wreck. And anybody who joins this train wreck in the future. Other than that, have a great evening and weekend, everybody. Peace out.